Welcome to the video on 9.7, part 3. Now we're going to look at some practice problems that describe how the graphs or functions move or change from the original parent function. We'll do square roots first. In number 1, I have minus 2 under the square root. That means I'm moving left or right. The 2 here, the minus 2, means the h value is positive 2. So it is moving right 2 units. The plus 1 on the outside is the up-down. Because it's positive, it's moving up 1 unit. In the next equation, we have plus 1. That means it's really minus negative 1. If h is negative 1, we're moving left 1. Remember, when you're inside the square root, you move opposite of what you would expect. We might expect that a plus 1 would move us to the right 1. It doesn't. It moves us left 1. Then we have the minus 3 on the outside. Because it's negative, I'm moving down 3. In number 3, well, why don't you put this video on pause, try number 3 on your own, and then check back in. Okay, I'm assuming you tried this already on your own. What does the 5 do? The 5 out front is our a value, so it is vertically stretching by 5. What does the minus 4 do? It moves us right 4. What does the minus 2 do? That moves us down 2. Okay, again, pause, try number 4, check back in. In number 4, we have a plus 2. Remember, the default is minus an h value, so our h value here is negative 2, which moves us left 2. The plus 5 on the outside moves us up 5. All right, now we need to think about domain and range. If you go back to our original notes on the parent functions, we know the domain for the square root of x is 0. Well, let me write it up here. For x, the square root of x, our domain is normally 0 to infinity, because we can't take the square root of negative numbers. So it has to be 0 or a positive number. Our domain will change if we are shifting left or right. So we want to be thinking about when we're moving left and right, or right and left. Here we moved right, here we moved left. All right, let me grab a different color. I'm going to do this in red, if possible. All right, so our domain, because we moved right 2, is going to shift to the right 2. So our new domain is going to be 2, comma, infinity, instead of 0 to infinity. In number 2, we moved left 1, so our domain becomes negative 1 to infinity. For number 3, I don't have a ton of room to work, but we moved right 4. That means it's 4 to infinity. And for number 4, we moved left 2. That means our domain is negative 2 to infinity. All right, the next question is, what is the range? Well, our range is going to be for the parent function. Let me do this in purple now. Parent function, the range is 0 to infinity, because the outcome of taking a square root can be 0 or a positive number. Our range is going to change only when we move up or down. So let me erase our domains here really quickly, so we have a little more room to work. And at this point, you should pause the video and try to figure out the domain and range for yourself. Then come back and check whether you found the range correctly. All right, number 1, we moved up 1, so our range has to move up 1. Our new range is 1 to infinity. In number 2, we moved down 3, so our new range is negative 3 to infinity. In 5, we vertically stretched, but a vertical stretch here isn't going to affect our range because we do 0 times 5, which is still 0, and infinity times 5, which is still infinity. But what will affect our range is moving moving down 2. If I move down 2, my range will move down 2. So my range is now negative 2 to infinity. And for number 4, I move up 5, so my new range is 5 to infinity. Alright, the same ideas apply for cube roots here in our next practice section. The only difference is the parent function looks like this instead of like this. So our domain and range are going to be different. The domain for the regular cube root is all reals. And I'm just going to write R for all reals. You could also write negative infinity to infinity. What's the range? Well, this keeps going up slowly, but it keeps going up and up and up to infinity, and this keeps going down towards negative infinity. So again, it's all reals, negative infinity to infinity. If my domain is all reals, is shifting left or right going to change it? No, it's still going to be all real numbers. If I shift the graph up or down, is it no longer going to be all reals? No, it'll still be all reals. So our domain and range won't change here by shifting left, right, or up, down. So I'm just going to write no change. So all we really have to worry about is how the graph is being transformed or changed, how the graph will look different. So at this point, you should stop the video and try to figure out, is my graph moving up, down, left, right? Is it being vertically stretched for numbers 1 to 4? Okay, checking back in. For number 1, we have a +1 on the outside. That's a vertical change. We're moving up 1. In number 2, we have a -4 on the outside. That means that we are going down 4. Are we moving left or right? Well, there's a -2 on the inside. That means we're moving right 2. There wasn't anything on the inside for number 1, so we're not moving left or right. In number 3, we do have a horizontal shift, left 3, but we also have a vertical shrink. It's a vertical shrink by half. Then a move left 3. Finally, in number 4, we're moving left 2, up 5. Okay, in the next practice problems, which is like your homework, you would want to, and like I said, this is for your homework, graph the parent function, so 0, 0, 1, 1, and then 4, 2. Then transform the function. So +3, that means I'm moving up 3. I'm going to move each of these points up 3. So 0, 0 becomes 0, 3. 1, 1 becomes 1, 4. And 4, 2 becomes 4, 5. And voila, we have our transformed function. The domain and range, domain, 0 to infinity, range, well, normally it's 0 to infinity, but we moved up 3, so it's now 3 to infinity. You don't have to complete the practice problems here or here, although I think they are good practice, and you may want to consider working on them before your test next week. However, there are a couple problems I do want you to do for homework, where it says match the graph with its function, or match the function with its graph. You should be able to tell from an equation like these which graph it matches to. I'm not saying these two actually match, but you should be comparing them. You want to think about, is this a square root function or cube root function? Is it moving up, down, left, right, or is it being reflected? Remember, negatives, which we studied before, reflect functions over the x-axis or the y-axis. In this case, these are reflections over y. All right, good luck. Don't forget to do your homework and study up.